Good morning, everybody. How are we doing today? I've got a bit of a problem, I'm going to admit to you. And that is this. Cool Math has been a fantastic summary of here's the bare bones, you need to know just these little things to do well in calculus. And so I like that as my outline for this course. I think it's worked fairly well. You tell me whether you'd prefer switching over to like some sort of traditional textbook with way more stuff to read and analyze. They're without necessarily more examples. Let me know if that's something you'd like to look into. But the problem has been, for me, part of the pace, and that we've taken these things that have been already condensed so down into such simple bite-sized bits, and then we've spread them out. It's like, oh my gosh, how do I fill a whole week with these two things that I could talk about in a day and be done? But I think I've found a way. And so what we're going to look at today, continuing with the rational functions, is I've created this list of functions. And I think for today and then next week, we will keep working on this same list of these same functions, but we'll iterate over them for each step of the solving / graphing a rational function process. Okay, so I think that's going to be how we can spread it out so it's not ever too much work on any one day, but still have a feeling of unity and like it all goes together. Aren't you absent, but you're in class right now? Well, that's because you weren't here when I started. So you're here now. I'll change that. There we go. Happy now? All right. I've only got the one class to teach today. You better believe I am starting at the time and we're going. Okay, there's no room for tardiness here. Anyways, so that's what we're going to do, all right? We saw last time how to generally create a graph from known information about a rational function. If you already know where the asymptotes go and where the intercepts go, how can you translate that into a picture? So now we're going to roll back and say, okay, how do I get that precious information out of the functions? Because it's just written like this. F of x equals gigantic thing. Oh my gosh, how do I deal with that? It's very simple. Most of the time, you factor. There is a reason we started there with all the factoring techniques and even the dividing polynomials techniques, because what you need to find are, first up, the zeros. You're always looking for zeros, right? The real intercepts, okay, come in two forms. There's the y-intercept and the x-intercepts. The y-intercept, of course, happens when the whole function is equal to 0. Now, since we're dealing with a rational function here, it is two polynomials divided by one another. This effectively is comes out of having only the numerator equal to 0, right? That's all we need. We don't need to worry about the denominator to find the y-intercept. For the x-intercepts, that is quite literally when I reversed that. I wrote those backwards. I am so sorry. What values of x cause the function to equal 0? This is when x equals to 0. There we go. That's what I meant to say. Sorry. The y-intercept, when x is equal to 0, where on the y-axis does the function cross? And we only care about the numerator there, right? Plug in 0 for x up top. What are you going to get? The denominator is going to come in with the excluded values. Right? So we'll come back to that in a moment. But for today, we're mostly focused on the numerator. Where does the numerator equal 0? Because that will cause the whole function to equal 0. Am I making sense, or have I confused you with my mistake there? Right? Just like any other function. Plug in x to get the y-intercept, solve the function equal to 0 to get the zeros. That's why we call them those. All right. Let's work through this one as an example, because number 1 is actually a little simple. The numerator is just 4. It's going to be really short. So let's skip ahead to 2, where we find some things are a little more interesting. Oops. I want my y-intercept, so I'm going to find f of 0. So we have 2 times 0 squared minus 0 minus 10 divided by 2 times 0 minus 5. What does that equal to? Well, that's 0, that's 0. We've got negative 10 up top. That's 0, minus 5, negative 5 on the bottom. So 10 divided by 5 is 2. There's my y-intercept. So I know somewhere on this graph it crosses up here, somewhere like that, like that, like that. I don't know how it crosses, but it at least crosses up there at y equals 2. And then for the x-intercepts, set the function equal to 0. And again, in order to create the whole function equal to 0, you only need the numerator to equal 0, because 0 divided by anything is still 0, unless the denominator is also 0. We'll come back and check that at the end. So start off 2x squared minus x minus 10. Doesn't this look familiar? This is solving a polynomial. In this case, it's a quadratic. It's x squared. Okay, so we can just factor that guy. It's going to be, let's do a little FBI here. 2x, and then divided by 2 to get the 10. And then x, 2 times negative 5 is 10. And 2 times 2x is 4x minus 5x. Yep. Okay. Follow your factoring process to get there, right? ZPP tells us from here, set either factor equal to 0 and solve for x from there. So x is equal to either negative 2 or add 5 and divide by 2. 5 halves, right? So here's my y-intercept. Here's my x-intercepts. And the only thing we have left to do now, and I didn't quite leave myself enough room here. Shrink that down. Is now we have an idea of where this graph should end up. But remember when we started with these, in simplifying the rational expressions, we wanted to find those excluded values. Where should the graph never be? And that's going to come from the denominator. So we're going to set the denominator equal to 0. Solve for the variable, and whatever numbers we get up, from there we know, oh, eliminate that from our list. The graph can never exist at that value. So in this case, 2x minus 5, where have I seen that before? So we just solve for x again. We get x equal to 5 halves, so there's my excluded values. Notice that my excluded value is one of the values I found for the 0. That's okay. In fact, that means something very specific about what's happening in this graph. It means that this is not actually going to show up as an intercept on our graph because it's been excluded. Right? But we'll talk more about that next week, the implications of all these numbers. For right now, we're just finding the Y-intercept, the X-intercept list, and the excluded values list. Okay, any questions there? No. Okay, then before you take off on the whole thing, go ahead and try number 3, and then report back in chat what you get. Okay, so write up Y-intercept. You can just go Y-int :5 or whatever it is, right? I don't feel like you have to type a whole sentence. Okay, that's one. Oh, there's the rest. Okay. Y-intercept, X-intercept. And excluded. Okay. Factor and solve that denominator. But otherwise, good so far. I thought this was a good pen. Guess I was wrong. Okay, Y-intercept, X-intercept. In the excludeds. Okay, Daniela's got an answer. Michelle, okay, I've got two conflicting results for the Y-intercept. Interesting. Daniela, make sure you are plugging in 0 into the whole function for finding that Y-intercept. And Isabel, you're onto something with the Y-intercept there. But it is not equal to what you think it equals. This one's a little tricky. Let's check this out. For our Y-intercept, let me use the smaller pen. There we go. Probably gonna look better. We need f of 0, so we gotta plug 0 in everywhere. 0 squared minus 0 minus 12 divided by 0 squared minus 4 times 0. So up top, that's nothing, all that's left is the negative 12. But we still have that denominator there. It does play a role for the Y-intercept. You want the whole value of the function, which means 0 squared minus 4 times 0 is 0. 0 minus 0 is 0. Uh-oh. You can't divide by 0. That's no good. So that means our Y-intercept, undefined. If our Y-intercept calculation is undefined, that means there is no Y-intercept. How is that possible? It's totally possible. Think about good old y equals 1 over x. Right? That was kind of sloppy. 1 over x has a vertical asymptote right on the y-axis. You can never set x equal to 0 for this kind of function. That's what we've got going on here. There's a case of, hey, wait a minute, 0 is one of our excluded values. The y-intercept itself is undefined. There is no y-intercept. Notice I said one of the excluded values. This is an x squared. There's two solutions to this quadratic here. And then double check the signs on your x-intercepts. I've got some good numbers reported back, but the signs are flipped, so I recommend everybody double check those. If you end up with a factor that says x minus 4, set that equal to 0, your x is going to be equal to positive 4. Okay, the sign changes here. All right, take a few more minutes. Double check, report back. Ah, see? Positive, negative, negative, positive. Okay, good, good. Okay. Ivan and Isabel, you both switched your signs from what you had to the complete opposites, but you both had different signs, so we still have no consensus. Are the 3s and 4s positive or negative? Sure, there you go. Although, to be fair, I was very brief on this process. It's factoring in ZPP, which we've done for years now. When you're looking for the X-intercept, you factor the numerator. When you're looking for the excluded values, you factor the denominator, the bottom. All right, well, let's clear up the confusion here. For our x-intercept, we want to set the whole function equal to 0. Because of the way fractions operate, the whole function equals 0 when the numerator is equal to 0. So that's all we need to focus on for solving this portion. All right? Now, since this is a quadratic, we can just factor this. Good old factoring rules. No GCF, no special product, 3 terms, so no grouping. So we'll just go straight to T-chart, factors of -12 that add to -1. A is 1, so I can go straight to answer format, x minus 4 times x plus 3. Okay? Which means we get x values of, this was x minus 4, so it's positive 4, x plus 3, so it's -3. And if we want to be prim and proper, we should reverse those, put smallest to largest. There we go. Okay? So there's our x-intercepts. But what about the excluded? That's where we're looking for where can we not have a value. And that would be wherever it would cause us to divide by 0. So wherever the denominator is equal to 0. Ooh, this guy does have a GCF, so factor out the x times x minus 4. So then you're looking at x is equal to either 0 or positive 4. Or rather, x should not be equal to 0 or positive 4, right? And so the 0, x equal to 0 itself, is what causes us to have an undefined y-intercept, because I'm not allowed to just plug in 0 to this whole thing to get the y-intercept. And then, yeah, we've got a duplicate here, 4 and 4, that's going to cause something to happen on our graph, which we'll see next week. Okay, final questions on these. None? All right, then go ahead and finish the rest of them. Yeah, I know the numbering restarts because I took them from 2 different sources. So you got 1 through 9 and then another 1 through 6. But that's it. Okay, have at it.